Hi, I'm Dr. Incognito. In this video, we're going to investigate the relationship between definite integrals and area. So when we calculate the integral from a to b of f of x dx using the fundamental theorem of calculus, how should we interpret our answer geometrically? So if the function f of x is a positive function, or maybe I'll write non-negative, over the interval from a to b, as we see in the picture here, then when we integrate, this numerical answer is the area between the curve y equals f of x and the x-axis, and between the vertical lines x equals a and x equals b. It's the area of this shaded region. So as an example, if we calculate the integral of 3 from 1 to 5, that's a pretty simple integral. In fact, we don't need calculus. Over the interval from 1 to 5, the function f of x equals 3 is a horizontal line, and therefore the region is simply a rectangle, and we don't need calculus to find the area of the rectangle. The width of the rectangle is 4, and the height of the rectangle is 3, and so the area is 12. So this integral should give us 12. Now let's just double check that. Even though calculus is not necessary to solve the problem, if we use our calculus technique, we should get the same answer. So the antiderivative of 3 that we seek is 3x from 1 to 5. So that's 3 times 5 minus 3 times 1, and that's 15 minus 3, which is indeed 12. Let's look at another simple example like that. The integral from 0 to 4 of x dx. So this one, the picture, y equals x, is a line at a 45-degree angle to the positive x-axis and going through the origin. And if this is the point 4, 4, then the region of interest is this triangle. The base of the triangle is 4, the height of the triangle is 4, so the area is 1/2 the base times the height, which is 1/2 of 4 times 4, and that's 8. So the answer should be 8. Again, calculus is not necessary, but let's solve this problem using calculus. It's presented as a calculus problem. So the integral from 0 to 4 of x dx, antiderivative of x using the power rule is x squared over 2. The power here, which is unwritten, is the power 1. So add 1 to the power and divide. And we have to plug in 0 and 4. So 4 squared over 2 minus 0 squared over 2, which is 8 minus 0, which is 8. Let's see, what happens if the function is negative? So suppose a function y equals f of x is negative, or less than or equal to 0 to be more precise, over the interval from a to b. Then when we calculate the integral, we get something that is related to the area of this region. What we will get is the integral, which will be calculated using the fundamental theorem of calculus. It will give us a negative value. And that negative value will be negative 1 times the area of the shaded region. Let's look at an example of that. Let's calculate the integral from negative 3 to negative 1 of 1 over x dx. So the antiderivative of 1 over x is the natural log of the absolute value of x, is the best answer. And you see that here x is in a negative interval, x is going between -3 and -1. And so it's very important that we put these absolute values here, because the log curve, y equals log x without the absolute values, doesn't even exist on this interval. However, log absolute value of x does exist. Oops, I should actually go through that. It doesn't exist. Log x doesn't exist in the left, but log absolute value of x exists on both sides of the y-axis. And so we can plug these negative values into this function. So we get the log of the absolute value of -1 minus the log of the absolute value of -3, which is the log of 1 minus the log of 3. The log of 1 is 0, so we get negative log 3. The natural log of 3 is approximately 1.1, so we're getting negative 1.1. And what does that represent geometrically? The curve y equals 1 over x is a hyperbola. If this is -3 and this is -1, then the region is this shaded region here. This region is below the x-axis. Our function was negative. When x is between -3 and -1, its reciprocal is negative. So the function here is in the third quadrant. Our region is below the x-axis. The integral is a negative number, negative log 3. So what that means is that the area of this region is equal to the natural log of 3. The integral gave us -1 times the area. -1 times the area, so the area is the natural log of 3. So in the last couple of examples, our function was either positive or negative. Now we'll look at an example where the function changes sign. So suppose you have over the interval from a to b, suppose the function changes sign. So when you calculate the integral, you'll still get a number. What will that number represent? If this shaded region has area A1, and this shaded region has area A2, then the integral will give us A1 minus A2. It'll give us what we could call signed area, where regions above the x-axis, like A1, are given a positive sign, positive A1, and regions like this one here below the x-axis is given a negative sign, so negative A2. As an example, we could look at the sine function, the integral from 0 to 2 pi of sine x dx. The function looks like this. Here's pi, here's 2 pi, maximum height of 1, minimum height of -1. And my poor drawing skills aside, the area of this region and the area of this region, they should be exactly the same. And so, according to what I've just said about sine area, this should be A1 minus A2, and these should be equal in area, so we should get 0. Let's do the computation. The integral of sine x from 0 to 2 pi, the antiderivative of sine is negative cosine. And then we can change that to cosine of x and switch the 2 pi into 0. So cosine of 0 minus cosine of 2 pi. And the cosine of 0 is 1. The cosine of 2 pi is 1. 1 minus 1 is 0. So the integral from 0 to 2 pi of sine x dx is 0. It's the signed area, and since these two regions are exactly the same size, the integral should be 0. How big is this area A1 is one last question we could tackle. What is A1? So to find A1, that would be the integral from 0 to pi of sine x dx, and that would be negative cosine of x from 0 to pi, which would be cosine of x from pi to 0, which would be the cosine of 0 minus the cosine of pi. The cosine of 0 is 1. The cosine of pi is negative 1. And so we get 1 minus negative 1, which is 2. So the area of this region here is 2. The area of this region then here is also 2. And so the integral from 0 to 2 pi being the signed area is 2 minus 2, which is 0. Okay, so there's a little look at the relationship between definite integrals and area. Thank you for watching.